The Mediterranean sun blazed down on the Capiterra airfield in southern Sardinia on the morning of June 12, 1943. Italian ground crew members went about their routine duties, maintaining aircraft and preparing for another day of operations in what had become a desperate war. None of them expected what was about to happen. At approximately 1100 hours, the distinctive silhouette of an aircraft appeared in the sky. But this wasn't one of their own. The twin-boom configuration was unmistakable. It was an American Lockheed P-38 Lightning, one of the most advanced fighters in the world, and it was coming in to land. The Italian personnel stood frozen in disbelief as the silver aircraft touched down on their runway, rolled to a stop, and sat there with its engines running. One quick-thinking Italian airman jumped into a vehicle and drove it directly in front of the Lightning, blocking any possible escape. The canopy opened, and a thoroughly embarrassed American pilot emerged, his face showing the moment of terrible realization. He had just landed at an enemy airfield. The pilot's compass had been malfunctioning, showing a bearing off by 30 degrees. After a long flight from Gibraltar, low on fuel and navigating over the featureless Mediterranean, he had mistaken Capiterra for his intended destination. In one navigation error, the Regia Aeronautica had just acquired one of America's most sophisticated fighting machines completely intact. The Lightning was quickly secured and examined by Italian technicians on site. Initial reports were rushed to Rome, where the news created immediate excitement among military leadership. Here was an opportunity to examine America's technological prowess up close, to understand what made this formidable aircraft so effective against Italian and German forces in the Mediterranean theater. The P-38G was carefully prepared for transport. American insignia were painted over with Italian dark green, slightly darker than the standard U.S. olive drab. White fuselage bands were added around the twin booms, and Italian Sabaudian crosses were emblazoned on the tail surfaces. The propeller spinners received a fresh coat of white paint. Within days, Lieutenant Colonel Angelo Tondi, the Regia Aeronautica's chief test pilot, flew the captured Lightning to the Guidonia Experimental Center near Rome. Guidonia represented the pinnacle of Italian aviation research and testing. Located northeast of Rome, this facility had seen some of Italy's most important aircraft development work. Now it would host an American fighter, and Italian engineers would have the chance to dissect every aspect of its design and construction. When the P-38 arrived at Guidonia, it created a sensation among the engineering staff. The aircraft was unlike anything they had worked with before. Its twin-boom configuration was radical, its construction methods were advanced, and its performance characteristics were extraordinary. But it was when engineers began examining the engines that they truly understood the gap between American and Italian industrial capabilities. The P-38 was powered by two Allison V1710 liquid-cooled engines, each producing over 1,000 horsepower and equipped with turbo superchargers that allowed the aircraft to maintain performance at altitudes above 25,000 feet. These were not simple power plants. They represented years of development by one of America's most sophisticated engine manufacturers. Italian engineers carefully documented every aspect of the Allison engines. They measured tolerances, examined metallurgy, studied the supercharger systems, and analyzed the counter-rotating propeller arrangements that eliminated torque effects. As they worked, a sobering reality began to emerge. This engine represented a level of manufacturing precision and technological sophistication that Italian industry simply could not match. Consider what the Allison V1710 represented. It displaced 1,710 cubic inches, hence its designation. The engine used a complex system of forced induction with exhaust-driven turbo superchargers that recovered otherwise wasted energy from the exhaust gases. The turbochargers themselves were engineering marvels, spinning at tremendous speeds while handling exhaust temperatures that would destroy lesser components. The engine featured an integrated cooling system with carefully designed passages through the cylinder block and heads. The oil cooling system was equally sophisticated, with radiators mounted in optimal positions to manage heat while minimizing drag. Every component had been designed with precise tolerances, manufactured with advanced machinery, and assembled with quality control procedures that ensured reliability. Italian engineers recognized immediately that the manufacturing techniques required for such an engine were beyond their current capabilities. The precision machining alone would demand machine tools that either didn't exist in Italian factories or existed in insufficient numbers. The quality of materials, particularly the alloys used in high-stress components, exceeded what Italian metallurgy could reliably produce. Italy's aviation industry in 1943 was struggling with fundamental limitations that went far beyond simple technical challenges. The country's industrial base had never been as developed as those of the major powers. While northern Italy had significant manufacturing capabilities, much of the country remained agricultural and rural, contributing little to war production. Italian aircraft manufacturers had traditionally relied on designs that could be produced with available materials and existing manufacturing techniques. This practical approach had resulted in aircraft that, while often elegant in design, lagged behind their opponents in crucial areas like engine power and manufacturing efficiency. The most produced Italian aircraft of World War II was the Fiat CR-42, a biplane fighter. While considered one of the best biplane fighters ever built, the fact that Italy was still mass-producing biplanes in 1943 spoke volumes about the state of their aviation industry. Other nations had moved on to all-metal monoplanes years earlier. Engine production was perhaps the most critical weakness. Italian manufacturers had focused primarily on radial air-cooled engines based on licensed foreign designs. Fiat used American designs, Piaggio used French Nomron designs, and Alfa Romeo used British Bristol designs. This fragmentation meant that instead of concentrating resources on developing world-class power plants, Italian industry was spread thin across multiple competing designs. The lack of high-quality engines had profound effects on Italian aircraft design. Unable to produce reliable engines of 1,500 horsepower or more, Italian designers often resorted to three-engine configurations for bombers. The famous Savoia Marchetti SM-79 bomber used three engines because sufficiently powerful twin-engine configurations weren't available with Italian power plants. When Italian engineers examined the manufacturing processes required for the P-38's engines, they realized the full scope of the challenge. The Allison factory in Indianapolis represented a level of industrial organization and capability that would take years to replicate, even if Italy had the resources to attempt it. Consider the scale of American production. By 1943, Allison was delivering approximately 20 engines per day. The company employed thousands of workers in a vast facility equipped with the most modern machine tools available. The production process involved hundreds of precisely coordinated steps, each performed to exacting standards. Component manufacturing for the V-1710 required specialized machinery. Crankshafts had to be forged from high-quality steel alloys and machined to tolerances measured in thousandths of an inch. Cylinder blocks required precision boring to ensure proper piston fit and compression. Connecting rods needed careful balancing to prevent vibration at operational speeds. The turbo supercharger system alone represented a manufacturing challenge that would overwhelm Italian capabilities. These devices operated at extreme temperatures and rotational speeds. The turbine wheels had to withstand centrifugal forces that would tear apart improperly manufactured components. The bearings required special alloys and manufacturing techniques to survive the harsh operating environment. Italian engineers calculated that merely tooling up to produce the crankshaft would require investment in new machinery and training programs that would take months, possibly years. The same was true for virtually every major component. The gap wasn't just in knowledge or design capability, it was in the fundamental industrial infrastructure required for modern, high-performance engine production. During this period, Italy was actually importing German Daimler-Benz DB 601 and 605 engines to power their most advanced fighters. The Machi C-202, considered one of Italy's best fighters of the war, used a German engine because no Italian power plant of comparable performance existed. Even when Italy licensed production of the DB605 as the Fiat RA 1050, production numbers remained limited, and quality control was problematic. The production figures tell the story starkly. While Italian engineers needed over 22,000 man-hours to build a single Machi C-202 fighter, German factories produced the similar Messerschmitt Bf 109 in 4,500 to 6,000 man-hours. This wasn't a small difference. It represented a fundamental inefficiency in Italian manufacturing that extended from aircraft to engines to virtually every aspect of military production. Italian fuel quality presented another insurmountable obstacle. The synthetic petroleum products available to Italy were of much lower quality than American aviation gasoline. This inferior fuel was more corrosive and provided less energy per unit volume. In fact, the captured P-38 at Guidonia would eventually be grounded because Italian fuel corroded the aircraft's fuel tanks that had been designed for the high-quality aviation gasoline used by American forces. If Italian engineers somehow managed to copy the Allison engine's design and begin production, the engines would still be compromised by having to run on inferior fuel. The performance would suffer, reliability would decrease, and maintenance requirements would increase. The entire system was integrated. You couldn't simply copy one component and expect it to perform as designed. The metallurgical challenges alone were daunting. American industry had access to high-quality aluminum alloys, special steels, and other advanced materials. Italy's access to raw materials was severely limited by the war. Bauxite for aluminum production was available, but processing capacity was insufficient. High-grade steel alloys required metals that Italy had to import, and blockades made this increasingly difficult. Quality control presented yet another obstacle. American factories employed rigorous inspection procedures at every stage of production. Components were tested, measured, and verified before assembly. The culture of precision manufacturing had been developing in America for decades, driven by the demands of automobile production and other industries. Italian factories, while capable of producing excellent individual pieces, lacked the systematic quality control processes necessary for mass production of complex machinery. Colonel Angelo Tondi actually flew the captured P-38 in combat during its brief operational career with the Regia Aeronautica. On August 11, 1943, he took off from Guidonia to intercept American bombers returning from a raid on Terni. Using the familiar silhouette of the P-38 to his advantage, Tondi was able to approach close to the bomber formation. He attacked a B-17 Flying Fortress, serial number 42-3307, nicknamed Bonnie Sue. The Lightning's devastating firepower, concentrated in the nose with 4 50 caliber machine guns and a 20mm cannon, proved highly effective. The bomber went down off the coast near Torvaianica, with 6 crew members successfully parachuting to safety. This single combat mission demonstrated the P-38's capabilities, but it also highlighted the insurmountable challenges facing Italian efforts to replicate such technology. The aircraft's performance, the power of its engines, the effectiveness of its weapon system, all of these represented years of American industrial development that couldn't be copied in a workshop or replicated with existing Italian factory equipment. The reality facing Italian engineers was stark. To produce engines like the Allison V1710, Italy would need to build entirely new factories equipped with modern machine tools. They would need to develop new steel mills capable of producing the required alloys. They would need to establish quality control systems and training programs for workers. They would need access to raw materials that the war had made scarce or unavailable. The time required for such an undertaking would be measured in years, not months. During World War I, it had taken American industry nearly 2 years to ramp up production after entering the conflict, and that was with a much simpler technological baseline. By 1943, with Italy already stretched to its limits and suffering under Allied bombing campaigns, such an industrial transformation was simply impossible. Moreover, even if Italy somehow found the resources and time to build the necessary infrastructure, by the time production began, the technology would already be obsolete. American industry was continuously improving the V-1710, increasing power output and reliability with each new variant. Lockheed was developing improved versions of the P-38 with more powerful engines, better superchargers, and refined aerodynamics. Trying to copy an existing design meant always being behind the technological curve. The captured P-38's operational career was short-lived. As mentioned earlier, the corrosive Italian fuel damaged the fuel tanks, grounding the aircraft after just a handful of flights. Reports suggest that Colonel Tondi may have engaged bombers on 1 or 2 additional occasions, but the exact details remain unclear. What is certain is that by early September 1943, the Lightning could no longer fly. On September 8, 1943, Italy signed an armistice with the Allies, fundamentally changing the war's dynamics. The Guidonia facility, where the P-38 had been so carefully studied, became a target for Allied bombing. Any hopes of using the knowledge gained from examining the American fighter evaporated, as Italy split between the Allies in the south and the German-backed Italian Social Republic in the north. The experience with the captured P-38 encapsulated a larger truth about industrial warfare in the 20th century. Technology alone wasn't enough. The ability to design an advanced aircraft or engine was meaningless without the industrial capacity to produce it in quantity. Manufacturing capability depended on infrastructure, raw materials, skilled labor, quality control systems, and economic resources. All of these factors worked together in a complex system that couldn't be quickly replicated or easily copied. American industry in 1943 represented decades of development. The machine tool industry that provided the equipment for engine factories had itself evolved over many years. The metallurgical knowledge that enabled production of high-performance alloys came from sustained research and development programs. The quality control systems drew on lessons learned in automobile manufacturing and other industries. This wasn't something that could be reverse-engineered from a single captured example. Italian engineers had recognized this reality as they examined the P-38's engines. The detailed reports they prepared documented not just what they found, but what it would take to replicate it. Those reports painted a sobering picture of the industrial gap between Italy and the United States. The conclusion was unavoidable. To build engines like those powering the Lightning, Italy would need factories it didn't have, using tools it couldn't produce, with materials it couldn't obtain, employing techniques it hadn't mastered. The story of Italy's captured P-38 offers insights beyond the specific technical challenges. It illustrates how industrial capacity served as a foundation for military power in modern warfare. Germany, despite its technical sophistication, ultimately lost World War II, in part because it couldn't match the industrial output of the Allied powers. The Soviet Union survived the initial German onslaught and eventually prevailed through a combination of vast resources and the ability to produce weapons in enormous quantities, even if individual units weren't as technically advanced as their German counterparts. For Italy, the industrial limitations were even more severe. The country had entered the war without adequate preparation, with an industrial base that was insufficient for a prolonged conflict, and with access to resources that became increasingly restricted as the war continued. Capturing an advanced American fighter provided valuable intelligence, but it couldn't bridge the fundamental gap in industrial capability. After the war, Italy actually did operate P-38 Lightnings, receiving 100 aircraft through a military aid agreement signed in April 1946. These aircraft, primarily late-model P-38Ls and F-5 reconnaissance variants, served with the Italian Air Force, flying missions over the Balkans and conducting various training and operational roles. The post-war P-38s were operated primarily by the 4th Stormo, along with other units. Italian pilots had mixed experiences with the aircraft. Many appreciated its excellent visibility on the ground and stability during takeoff. The twin-engine configuration provided a safety margin that single-engine fighters lacked, particularly important for pilots still building experience after the war's devastation of Italian aviation. However, the P-38s in Italian service suffered from high accident rates. At least 30 crashes were documented, with many proving fatal. Several factors contributed to this. The aircraft's size and complexity required careful handling. The engines were old and worn from wartime service, and spare parts were limited. Pilots transitioning from smaller, simpler Italian aircraft found the Lightning demanding. Additionally, Italian maintenance practices and infrastructure weren't ideally suited to the P-38's requirements. The aircraft demanded regular, meticulous maintenance and access to specific tools and equipment. Italian facilities, still recovering from the war's destruction, often lacked these resources. The result was aircraft that, while potent when properly maintained, proved challenging to keep in reliable service. The P-38s remained in Italian service until 1956, when jet aircraft finally replaced them entirely. Ironically, not a single component from these Italian P-38s survives today. The aluminum alloys used in their construction were too valuable in the post-war period. The aircraft were systematically dismantled and recycled, their metal reclaimed for other purposes. The historical value of preserving these aircraft was overshadowed by the practical need for materials in a country rebuilding from war. The experience of examining the captured P-38 in 1943 left lasting impressions on Italian engineers who participated in the evaluation. After the war, many of these engineers contributed to Italy's recovery and eventual emergence as a significant industrial power. The lessons learned about precision manufacturing, quality control, and systematic engineering would eventually be applied in Italy's post-war industrial development. Italian industry did eventually master advanced manufacturing techniques. Companies like Fiat, which had struggled to produce competitive aircraft engines during the war, became globally respected manufacturers in the post-war era. The aerospace industry, though it never reached the scale of American production, developed capabilities that would have seemed impossible in 1943. But in that summer of 1943, as Italian engineers studied the Allison engines of a captured P-38 Lightning, the gap seemed unbridgeable. Every measurement they took, every component they examined, every system they analyzed reinforced the same conclusion. This level of technology required an industrial infrastructure that Italy simply did not possess. Building the factories necessary to produce such engines would require resources Italy didn't have, time that the war wouldn't allow, and expertise that would take years to develop. The machine tools alone would need to be imported or built from scratch. The metallurgical facilities would require complete modernization. The quality control systems would demand cultural changes in how manufacturing was approached. Even if all these obstacles could somehow be overcome, there remained the question of whether copying the Allison engine was the right approach. By the time Italian-built versions could enter production, American engineers would have moved on to even more advanced designs. The V-1710 itself was continuously being improved, with each new variant incorporating lessons learned from operational experience and pushing the boundaries of performance. The captured P-38 at Guidonia represented more than just an aircraft. It was a tangible demonstration of the industrial might that lay behind American military power. Each precision-machined component, each carefully designed system, each integrated solution to complex engineering problems reflected the accumulated capabilities of American industry. For Italian engineers examining this aircraft, the experience must have been both fascinating and frustrating. They could understand the principles involved. They could appreciate the elegance of the solutions. They could measure and document every detail, but they could not replicate it. Not with existing facilities, not in any time frame that would matter for the war. Not without fundamentally transforming Italian industrial capacity. The knowledge that it would require building new factories was more than a technical conclusion. It was an acknowledgement of a deeper reality about industrial warfare. Success in modern conflict demanded not just good designs or brave soldiers, but the economic and industrial foundation to sustain production of increasingly complex weapons in vast quantities. America's advantage wasn't primarily in having better engineers or smarter designers. It was in having an industrial system capable of turning designs into reality at scale. The United States could not only design the P-38 Lightning, but could produce thousands of them. They could continuously refine and improve the design while maintaining production. They could provide spare parts, train pilots, and support operations across multiple theaters simultaneously. This was the lesson that the captured P-38 taught Italian engineers. Technology transfer wasn't simply a matter of obtaining drawings and specifications. It required the entire industrial ecosystem that supported advanced manufacturing. Without that foundation, even the best designs remained theoretical. As Allied bombing intensified in the final months of 1943 and into 1944, facilities like Guidonia became increasingly vulnerable. The experimental center suffered damage from air raids, disrupting research and testing activities. The captured P-38, already grounded by fuel system problems, became just another damaged aircraft among many as the war's tide turned decisively against the Axis powers. The twin-boom fighter that had landed by mistake in Sardinia that June morning had served a purpose, though not the one its designers intended. It had provided Italian engineers with a detailed look at American technical capabilities. It had highlighted the enormous gap between Italian industrial capacity and that of the United States. And it had demonstrated that in modern industrial warfare, having access to advanced technology wasn't enough. You needed the factories, the tools, the materials, the knowledge, and the systems to produce that technology at scale. Today, historians studying World War II often focus on battles, strategies, and military leadership. But the story of Italy's captured P-38 reminds us that industrial capacity formed the foundation upon which military power rested. Without the factories to produce the weapons, without the infrastructure to support operations, without the industrial depth to sustain production, even the most brilliant military strategy or bravest troops faced insurmountable disadvantages. The Italian engineers who examined that P-38 understood this truth. Their reports documented not just what they found, but what it would take to match it. The answer was clear. It would take new factories, new tools, new materials, new skills, new systems. It would take, in essence, a different industrial base than Italy possessed in 1943. The gap was too wide to bridge, the war too far advanced, the resources too limited. So the P-38 sat at Guidonia, a monument to American industrial might and Italian industrial limitations. Its Allison engines, marvels of precision engineering, represented capabilities that Italian factories couldn't match. Its advanced systems, from turbo-superchargers to counter-rotating propellers, embodied knowledge that couldn't be quickly transferred or easily replicated. For the Italian engineers who had hoped to copy these engines and incorporate American technology into Italian aircraft, the realization was sobering. They would need new factories. And those factories, with everything they represented in terms of capability, infrastructure, and industrial sophistication were beyond Italy's ability to create in the time available. The war would end. Italy would rebuild. Its industries would eventually develop advanced capabilities. But in 1943, facing a captured P-38 Lightning and its sophisticated Allison engines, Italian engineers learned a hard lesson about the realities of industrial warfare. Advanced weapons required advanced manufacturing capabilities, and those capabilities couldn't be copied from a single captured example, no matter how carefully it was examined. The story serves as a reminder that in the modern age, military power rests not just on the battlefield, but in the factories that supply it. The captured P-38 demonstrated this truth as clearly as any battle. Technology alone wasn't enough. Production capability was king. And in 1943, that capability resided primarily with the Allied powers, particularly the United States, whose industrial might would ultimately prove decisive in the war's outcome. This was the lesson of the Lightning that landed by mistake in Sardinia, a lesson about industrial power, manufacturing capability, and the foundations of military strength in the 20th century. Italian engineers tried to copy what they found, but they quickly realized that copying required more than knowledge. It required factories they didn't have, couldn't build, and wouldn't have time to create before the war's end. The P-38 had revealed not just American technical sophistication, but the vast industrial gulf that no amount of engineering skill alone could bridge.